So let's continue with our functions of multivariable functions. So here we have an example, a little bit more of a word problem so that you guys can kind of see what's going on. And we're going to be doing something like this later on at the very end of the chapter. So let's say we have a company manufactures 3-speed and 10-speed bicycles. So it costs $100 to make each 3-speed bicycle, and it costs $150 to make each 10-speed bicycle. So if fixed costs are $2,500, find the cost function, and then use it to find the cost of producing 15 3-speed bicycles and 20 10-speed bicycles. Okay, so this question is actually pretty straightforward. We already know the cost functions, right? We know that the cost is going to be my variable costs added to all my fixed costs. So we've done problems like this before. Now here we have two different things that we have to construct. So we have the cost of a 3-speed bicycle. I'm just going to label that as X. X is going to be how many 3-speed bicycles I make, or I spend to make them. And then I'm going to just say Y is all the 10-speed, okay? Because I'm also building those, so 10-speed. So it's cost to build these guys. Okay. So now what I want to do is I want to find the cost. So my cost, and I'm going to write it this way. My cost function, which is C of X comma Y, so the cost of both of those two different things, is going to be my variable cost. Well, if X is my 3-speed bicycle and I make X amount and it costs me $100 to make them, then 100 times X is going to tell me what the cost of making X 3-speed bicycles would be. Okay, that's what that means. So that times that. Okay, the price times the quantity. So the cost of this times that will give me the cost. Now, how much is it going to cost me to make Y 10-speed bicycles? Well, it cost me $150 to make them. So I'm going to add the $150 times Y. So that's how much it cost me to make these 10-speed bicycles, or Y of them. So if I wanted to make 10 of them, then it'll cost me $150 times 10. And then finally, obviously, we got to pay rent or whatever else we got to do. So our fixed cost is $2,500. So this guy would be considered my fixed cost. It'll be $2,500. Okay, so this would be my cost function. Okay, and now finally, all we're doing is we want to know what exactly the cost will be if I make 15 3-speed and 20 10-speed. So all I really got to do is just plug it in. So I'm going to plug in 15 for X and 20 for Y. So I'm going to get 100 times 15 plus 150 times 20 plus 2,500. Okay. So let me put that in my calculator. So 100 times 15 plus 150 times 20 plus 2,500. That's going to give me about 7,000. Okay, so that is how much it costs to produce, or how much it costs to produce 15 3-speed bicycles and 20 10-speed bicycles. Okay, so you might be wondering that this is actually where exactly multivariable functions appear. Well, one of them is costs. So when we talk about costs, that's when these guys tend to appear a lot, especially if you have costs of many different products. So if you have more different things, if you sell more than just one item, then you actually have a multivariable equation, a multivariable function in 3D, 4D, whatever, depending on how many products. The number of products is almost going to determine how many dimensions you're going to be in. So here I have some other additional examples of where these two functions appear. So the Cobb-Douglas production functions for all my business people. Here, A and B are constants. P is my total production. So how much production do I make when you have L, where L is the units of labor, okay, kind of like work hours. And K is the units of capital, okay, kind of like raw materials. So you can find the total production, something called the Cobb-Douglas production functions, which is actually a multivariable function because it takes into account two different things, labor and capital. Okay, so that appears in many times. When you take maybe a microeconomics a little bit more advanced, you're going to see this formula a lot. If you want to find the total antibiotic effect of two or more medications, so if you gave a patient two different types of medications and you want to know what the antibiotic effect of those two medications are, you can actually model it using a multivariable equation. And it occurs a lot in statistics and in psychological studies. So if you have many different variables like hours of practice and rest to try to predict the score. So this is maybe my X and my Y, and this will be my Z. So if I want to predict my score based on hours of practice and rest, I can try to do that. This is more statistical. So this is more of in a stats class. So if you take a stats class, you'll be doing a lot of that. So just to give you guys a little bit of an overview of where exactly these guys come from. And we'll do a couple of examples later on in the chapter.